Of Kelley Green Biofuel. This talk is a co-talk between Link, Shumaker, and myself. We initially had planned to just speak about the methanol recovery system that we designed and implemented together. It sort of grew to sort of an overview of the company and some processes. So you're going to get both a definite emphasis on methanol recovery at the end. A little bit about Kelley Green. I started it just after graduating from college in 2008. I guess we'll go on to the next page. After college in 2008, and I was in a situation, I did a business plan for something much more grandiose than was possible financially for me to start. So I did the business plan and then was like, okay, how can I actually start this? And it was either build a small plant or start collecting vegetable oil. So I got some contracts. Fabricated a vacuum collection truck, or at least the collection portion of that. Started getting contracts, then I had the oil and no way to process it. So started doing the research and began building a plant in 2009, personally building it with the help of one other person, a welder at that point. It was up until a year and a half ago, 2 years ago, it still took like I was making fuel and using fuel, but it was like 16 hours to make a batch, and I was absolutely the only person that could have done it in that setup, so it was like not an economically viable model at all. I went to a dinner that I was semi-invited to, met Lyle. The only thing I knew about Piedmont was that my childhood pediatrician's son had worked there. And so I was like, do you know Link Shumaker? I didn't even have his first name, and it's like Link just left Piedmont. I cold called Link, asked if he had ever done consulting work. We started working together and have drastically improved the process over the course of, I guess it's like a year and a half, something like that. So that's sort of the background. Some interesting things that it's a 75 to 100,000 gallon a year plant, and some of the interesting things that we're able to do is almost totally water-free, no water washing, like 10 gallons of water per 355 gallons of fuel produced, something like that. We use very low or no energy oil pre-processing, and some innovative side stream processing, all of which we'll talk about. The rest of my personal background is that I grew up on a farm that was way more helpful than going to college for this business. My dad was a proponent of renewable fuels before you heard much about it, from the soy and corn side, and that's the rest about me and the general of the company. Hand it over to Link to talk about some process specifics and stuff.
Okay, hi, Link Shumaker. I went to University of Kentucky. I have an engineering background. I entered the industry in 2007 here at Piedmont Biofuels. I've worked in production or some sort of hands-on biodiesel processing pretty much nonstop since 2007, and it's no easier and no less exciting today as the first day that I started. So that's fun about the industry. Let's see. So Kristopher and I started working in 2012 together, and we have, I think that what Kristopher has is a model plant of a 70 to 100,000 gallon per year facility that is in very good order. It's got some good safety features. It has some really good process in place, and so I'm excited to talk to you about it and show you all what we've come up with, and hopefully that you can take some ideas out of it, and it can generate some good conversation. So let's see. This is an overview of Kristopher's process. He's bringing in oil so these tanks here are 300 gallon, I'm sorry, 500 gallon propane tanks. We'll show some pictures later, but after oil is passively settled outside without the help of any boiler heat or process heat, it gets pretty clean just from passive settling through some hot summer months. And so to do a final polishing, we bring it into a propane tank with the top cut off, and we'll do some recirculation to let the last amount of moisture out. So typically we're seeing 500 to 1,000 ppm moisture in the oil going into the reactor. And so we'll send the oil in, and the FFA tends to be less than 3%, so really good supply of oil. So there's no acid esterification, there's no glycerin, like caustic stripping wash or anything. We just do a straight sodium hydroxide methoxide, sodium methoxide mixture that is mixed in the reactor. That's with, is that a 50 gallon per minute pump or 100 gallon per minute?
It's like 90.
90 gallon per minute pump. So a big pump here recirculating in this closed upright propane tank. So it's a nice tight system. It's vented out of the building, but it really, the vents are closed during reaction, and we do a headspace exchange with the, let's see, methoxide mixer. Here we go. So when we're loading the methoxide into the reactor, the headspace of this is displaced back into here, so we're not pushing those methanol vapors out. So it's a pretty standard two-stage reaction, very reliable. And the fuel will go through, we do about a 2-hour settle on first stage to get the first amount of glycerin out. And then once we start second stage, as soon as we pass 27.3 and get a good clear result on that, we send it straight through the centrifuge. And so the centrifuge really cuts, in my mind, a day off of settling. So we can start a batch in the morning and be completely finished with methanol recovery that same day in about 5 hours. Without having to do the second stage settling. So that's a nice sort of lean aspect to the process that we can get all the way through the batch and have the reactor empty and waiting the next morning. So the fuel will run through the centrifuge, and then it goes straight to a heat exchanger that's running on low pressure steam. That's at 15 psi steam pressure, and then it goes straight into a flash drum, which we'll show some pictures of and really get into some of the nitty-gritty of what the temperatures are and pressures are there a little bit later. But the fuel sprays into the flash drum, the methanol comes over and is condensed and sent back in for the next batch, and the fuel goes into a settling tank. The glycerin comes out before it goes into to methanol recovery and is sent to a storage tank, and then we do further processing here. I didn't show it on this diagram, but there is some more processing that happens to generate some boiler fuel that will that heats the whole process. So we're really generating enough boiler fuel to heat this whole process to do it, especially the flash is where a lot of the heating comes in, and heating up the oil. That's where the biggest heat demands are. And we're generating plenty of boiler fuel to do that and to sell in excess of boiler fuel. So there's another value stream there. After we're in soap settling, we let it sit here overnight. So what we've done is, instead of flashing this to be within spec for flash point at 130 Celsius, which is kind of a hard thing to hit with fuel that has a lot of soap in it. So if you have waste vegetable oil based biodiesel, you're going to have an amount of soap in your fuel, and what we found is that the soap wants to hang on to some of the methanol more than the biodiesel does. So you have to either heat this up hotter, bring a deeper vacuum here, or come up with a way of being satisfied without getting the flash point into spec immediately from the flash drum. And so that's what we've done, saving money on heating here, and put a really simple fan on this tank, blowing into the headspace and blowing out through a vapor recovery system. That brings the flash point from, say, 70 Celsius all the way up to 130 overnight, really simply.
Let me interject one thing. By not making your flash point in spec in a single pass, it's like the difference in, we have a really nice vacuum pump, so we're running at like just over 28 inches of vacuum. But with a low pressure steam boiler, you can't generate enough heat to do that in a single pass. So it's a difference in like running low pressure steam and not knowing that you can, and we struggled with that for a long time, being able to leave it out of spec in that initial, as it's exiting the flash. drum.
Yeah, so that gives a lot of flexibility on how to design the methanol recovery system. So after the soap settling tank, we send it back to the centrifuge one more time. We end up in here with about 400 to 600 parts per million soap and very low moisture. And then we go through resin columns and into this biostorage tank. And we've done numerous full slate tests on the fuel, and it's coming out reliably. So let's see, did I cover all the highlights that are listed here?
Something that I should have mentioned also, this is a very small plant, and if you're thinking about numbers and things, what we're able to produce on-spec fuel routinely, but I've also been able to help pay the bills by selling vegetable oil to other biodiesel producers. So I really operate it as a pilot plant. So anytime that there's the opportunity or an idea to increase efficiency, I explore that, risk delays, risk batches, to do that in the hope of very high yield and efficiency in the future. So it's the goal is to work out everything and come up with a process that I'm really happy with before building a larger facility or more than one larger facility that would not be operated on a pilot basis, essentially.
And there's another aspect of this plant that doesn't show up on this drawing here, that it's a vapor recovery system that we'll look at in a little while that really reduces the overall emissions of this plant from fugitive emissions coming out of vents and things like that. So let's take a look at what this plant looks like. This is the production room. This is the reactor here. The oil cleaning tank would be right here. And so this is a vertical 500 gallon propane tank. These are the controls. And so that's where we'll send in our oil, do the reaction. This is where we mix our methoxide. We have an air actuated mixer up here, so we're running off compressed air to do the mixing. It's a completely spark-free system. We load it using vacuum, so there is no direct pumping of methanol, or I'll say that the methanol doesn't actually go through a pump, so it saves on some of the special design that you have to have for a pump that can handle methanol safely and that level of spark resistance, explosion proof design. So the catalyst comes in through this, is that a 4-inch PVC pipe? Yeah, 4-inch pipe. There's a second story kind of loft you can see here where we'll weigh out the sodium and then we'll take it up the steps and pour it into a hopper, and it comes down there and lands in the mixer. And of course we have a sight tube. And this is the head space exchange right here that ties into the reactor so that we keep those vapors in process rather than pushing them out to the atmosphere. This is the centrifuge. I would say it's probably one of the biggest single pieces of equipment in terms of cost, complexity, and a lot of the process is really designed around it. I think that what it does is allows us to not use water, to move a batch further along in a given amount of time are the two main things that it does. And it's really a pleasure to work with after you know it, but there are a lot of variables that a person has to learn to balance. So there's some training that goes along with figuring out how this thing works and what its idiosyncrasies are. And the biodiesel will come out this pipe, and that will head over to methanol recovery, and the glycerin will fall out into this basin here, which is connected. It has a level gate, a level actuator, thank you, yeah, float valve on in this tank that as the glycerin builds up in here, it turns on this pump, and that pump sends the glycerin out to the storage. This is the methanol recovery tank, so we put it outside. It's an identical tank to the reactor, except that it has a different kind of stand. It's got a condenser here. The pipes feed in here to spray the fuel in, and as we move through the process, we'll come back and revisit the flash drum in a little more detail. So after the flash drum, the fuel lands in the soap settling tank. You can see the vent here goes to a vapor recovery system. And then at the end of the day, we flip on a fan and it pulls off the top of that overnight. And that takes the flash point from, say, 70 degrees Celsius up to 130, or at more than 140, I'll say. I've never actually taken it to the flash point, but gone 10 degrees over spec.
And something that we took a long time to learn is that the centrifuge, at least how my centrifuge and how I know to operate mine, does not do an effective job of removing heavy globs of soap. That I can't get it to do that. I can't get the soap to flow out the heavy phase the way that I would think it would. But letting the heavy soap go to the bottom and centrifuging off the top, still very soapy biodiesel, but the centrifuge will knock that soap down without without gumming up, I guess, or making an emulsion in the bowl of the centrifuge.
Yeah, so after you take out the methanol, the soap wants to come out, and that's not trivial to deal with. It doesn't filter out like a solid would filter out. It's kind of a gooey sludge, and it will bind up your fuel so it can hit your yield. So a lot of the work that we have done and are doing is learning how to concentrate that soap into a smaller and smaller space so it doesn't bind up yield. And how can we do that without increasing the moisture of the fuel so that we don't have to spend a lot of time drying it or heating it or whatever it takes to get the moisture out of the fuel. And so we have this arm here that is, it goes in, so this is an old milk tank, and a lot of the materials that this plant is built out of is old milk equipment that it's lined with heating coils that are well engineered, were well engineered 50 or 70 years ago, and so repurposing this equipment has been really a pleasure to work with. It's nice stainless steel too.
And they're obviously, with milk equipment, originally Freon coils, so but you can plumb steam into them and they work just fine as heat.
So this arm here is, it slides into a port, and we have a hose clamp on there, and we can adjust this. So we have a sight glass here, or a sight tube, and we can adjust this to pull off higher or lower levels. And so our goal is always to get the soap as low as possible down into the tank, and then pulling the fuel off the top. And then depending on how well we can concentrate the soap, we will pull that out and do some kind of process to that to ultimately recover value from the soap and get all of the yield out of the soap. But that's a separate process from here. And the ultimate goal is to use every bit of the FFA and every bit of the triglyceride to enter the system. So if it gets turned into soap, then we're going to go process that later and add acid to it and convert that back into FFAs, dissolve that into out-of-spec esters and make a boiler fuel out of it. So it'll be like a high FFA, essentially a high FFA out-of-spec fuel stream that may not be fully reacted. It might be some monos and dis and maybe even some tris in it, and a lot of FFAs, maybe 15% or something like that, but it burns great in a boiler. So these are the resin columns. After the soap settling tank, the fuel runs back through the centrifuge that'll knock the soaps from maybe 1,000 ppm down to about 600 ppm, and the resin columns at like 300.
There's a second holding tank outside of this building. So it goes through the centrifuge into a holding tank, gets agitated some more to let the very last of the methanol out, and then through the resin. So before the resin, sitting in the holding tank before the resin, we're looking at a flash point of above 140 Celsius, soap number of, let's see, between 150 and 300, and moisture of well under 1,000 ppm. So we're really not asking much of the resin columns. That we get good life on the resin. So to measure yield, there's a pretty special meter here. This is a positive displacement meter that I don't remember how much it costs. What was that? I got it on eBay, so it was like 400, but I think they're 18 or.
So new, they're like $2,000 or something, but you can find them for cheaper on eBay. And that's a very accurate meter that we're using to measure the fuel produced coming out the final stream. And so that's for RINs recording and for yield calculations and things like that. And then this is the feel-good sight tube, so you can watch the beautiful fuel coming out the end of all of the work.
What was that meter called again?
That's a GPI GMOO3 1/4-inch positive displacement meter. This is before dairy barns had stainless steel piping. It was all glass. If you've ever been in an old dairy barn, that's a little section from an old dairy barn.
So this system here is pulling, this is a little circulation pump that's pulling from the final storage tank, and it is running through this heat exchanger here, so it's a way to heat the final storage tank. So this is a control valve on a steam pipe that comes down and heats this, this shell and tube heat exchanger, and that's a pretty standard jacuzzi style heat exchanger. You can find them on eBay all day long. And it comes out to a little steam trap. So steam goes in here, and as it's condensed into water, it will pass through the steam trap and return back to the boiler. That's us having fun making fuel. Never a dull moment. And this is the lab.
Yeah, so got a couple slides about some of the little things that we've made work in our small system, I guess. We have a pretty functional production lab, and especially before Link, I really struggled with like what equipment to buy, what's good enough and what's not good enough. So what I've come up with, I guess, is a fairly accurate scale. We do obviously titrations coming in. We do acid number. We use a sandy bray for moisture. We have a real flash point tester. And we do, for glycerin, we don't have anything better than 27.3, so we've got the go, no go for 27.3. I think that's mostly what the lab is. So outside testing, we'll do full slates, but we also use QTA on their on-demand program. You may be familiar with that. That uses near infrared to do not everything, but especially for like free and total glycerin is I think now accepted as ASTM standard via that method. So QTA on demand is a very good intermediate when you don't need to do a full slate, but you still need some real numbers. Definitely, like what's most lacking is in process, especially for altering processes. Total glycerin don't have accurate numbers on that in the lab. Okay. This is just like an organizational thing, but something that has legitimately made everything more enjoyable. We did an intentional bucket system, color-coded, so that like all those little odds and ends that you never know exactly where to go, you never have a barrel of a bucket clean enough, we do now. So yellow is anything that is like clean oil, anything that can go like in the cleaning tank. The blue has methanol in it, glycerin, underreacted fuel. So anything that we know isn't in spec or glycerin, or anytime we're draining out like the very last glycerin out of something, goes in the blue bucket. That all gets sucked back in the processor. So this is like going from empty to just having a little bit in it, lid on it to keep the methanol vapor contained. And then green is only in spec fuel, so that can always go in the pre-resin tank to go right through the resin. But it's, there's definitely like a few gallons every day that are saved by going to always their highest possible value location. Lab waste has its own situation and goes into the boiler.
And notice that these are the two buckets that might have something that has methanol in it, especially this one, so they've got lids on them. And those are really easy to find at US Plastics. But we've done a lot to keep just the ambient methanol fumes down and out of the shop.
So the other major thing that we did to keep methanol vapor down, it turned out to be a way larger project than we really anticipated, but it was this vapor recovery system. So any tank that has the potential of having methanol vapor is connected to this vent system. It's just a trunk line with PVC lines running off of it with gate valves at each tank. And so this is an explosion-proof motor on a VFD drive, so you can control the flow of air. And so selectively, if you're running the centrifuge, which has an open top to it, there used to be vapor that would come out in the room. Now we just have the pipe that goes down in that headspace, sucks it out. We have a portable methanol detector, and it's totally safe methanol levels in the room, in the production room. Yeah, so it goes through this fan into a custom-built trap with heat exchangers inside. So any methanol vapor that would have enough methanol to condense can condense and drop out and drain out the bottom of the bucket. Super wet, you can't use it back in your process, but can go in the boiler. Also have a second trap here that is tied into the exhaust of the vapor recovery system, and so this is our higher quality methanol coming from the output of vapor of the vacuum pump and the output of vapor from glycerin storage, both of which are in the neighborhood of like 95% purity, so still not great. Looking at ways potentially with a mole sieve to get that content drop down so that can go back in the system, but we're getting like depending on it, especially the heat that we put in the glycerin tank, substantial quantities of methanol to reuse there with like pretty low energy being put into the glycerin tank.
And that methanol is all vapors that would be going into the atmosphere. So that is straight up preventing our greenhouse gases from being emitted and then putting that back into the system. So
and these have stainless steel wires running through to bond them. So it is like that is an issue with running methanol vapor through plastic pipes. So
yeah. So if you set up a system like this, be aware that you need to ground and bond across metal components, because this plastic can build up a static charge, and so if you're blowing air through there through a plastic pathway from metal to metal, and there's a lot of methanol fumes in there, it's really a classic safety hazard that it's more a matter of when than if that would kind of send a pressure bomb through there with some flame.
okay, so we're also processing glycerin now. So Link mentioned making boiler fuel from that soap out of the bottom of the soap settling tank. We've also had a lot of luck making boiler fuel from our glycerin. So just the crude glycerin that comes out of the process. Ours still has methanol in, or almost all the methanol in. And what we're doing with it is neutralizing that with HCl, hydrochloric, and seeing, after we get it neutralized, we're seeing a very clear split. We're getting glycerin off the bottom, which is, I haven't sold a load of that yet, so I don't. It may not be hardly any higher value. It's certainly, I don't believe, lower value, but getting lots of what we call gesters. There's definitely esters in there, but we're not, it's a guess exactly what the composition is. We're using that in this boiler, working very well. I will say, I bought this boiler from Ag Solutions in Kentucky. Was one of the worst decisions I've ever made. I would strongly encourage you not to. It was, I think, bigger than they generally sell. He had no idea about the design of it. This is a total redesign that I did through 2 years. But so anyway, there are considerations that you need for burning lower quality fuel. You need heat close to the nozzle. You need continuous ignition with electrodes, and you need fuel consistency. All of these things were like very hard lessons learned, but now have a nice boiler that burns this very low cost feedstock derived from the glycerin, which is certainly more than I think the last load I sold before this was like maybe 2.5 cents a pound. So I'm getting way more value burning it, and then have this excess. I haven't built up a load of the excess boiler fuel to sell. I've got I've got lots on hand, but haven't sold a load, so I don't know the exact value of that. Been selling very comparable stuff to someone at like $2 a gallon, so I don't know what it will end up being, but it is a really nice boiler fuel.
Yeah, so this Gester fuel that we've been making and burning, it comes mostly from the glycerin, but any soapy sludge that comes off the process we can also mix in there before we add our acid, and that just adds to the yield of the Gesters. So it's a significant stream that I encourage you to look at for an added value stream and a way to heat your process.
And something else that's awesome is after the glycerin is neutralized, it will no longer solidify. So there's no need to heat your glycerin after you do this process.
Okay, so this is a lot of information on the flash system. And maybe before we jump into this, something that I just want to say about the overall process, things like the bucket system and the orderliness of the lab, is that my experience in seeing production happen is that I don't know how to put a number on the value of having something like an orderly bucket system or an orderly hose system or an orderly lab, but I'm convinced that it's a big number. I'm convinced that the way a production facility should run, it should be very orderly, and things should have their place, and they should go back when you're finished with them, and you should know where they are when you need them. And the amount of time and effort that I think is wasted on digging through a pile of tools, trying to find that one tool that I might have left on the boiler 3 weeks ago, or on the reactor or whatever, is just I think that we need to reclaim that wasted time and effort for our industry to really move to the next step. And so I think that a lot of the details of how this plant is put together and how the production philosophy is laid out are a really big part, as big as how the piping is run and what the recipe is for the success of the facility. And so with that, we can move into the methanol recovery system. So I think that in general, for a transit esterification process, that the methanol recovery system is one of the more complicated pieces to figure out. I think that figuring out how to get a reaction in spec reliably is a little easier than figuring out how to safely and reliably run a methanol recovery system. So I wanted to take some special time to show some details of how this process works, because it works for us reliably, and I think that it's important information for our collective to take a look at, and of course there'll be copies of this. There may be more information on here than we can totally digest in this sitting, but this is a good reference, and maybe your system isn't identical to this, or if you're building a system it won't be identical to this, but this will give you some ideas of what to shoot for. So what we're doing here is we're running about 385 gallons of oil into a batch. We're seeing about 365 gallons of fuel coming out. So we know that there is an amount of esters in the glycerin that we're losing. So this number is after first stage glycerin is separated, and then after the centrifuge, we end up with 365 gallons of fuel coming out of a 385 gallon batch of oil. And that's going to be traveling into a heat exchanger. After we're in spec, for 27.3, we're going to travel through a heat exchanger at about 5.5 gallons per minute, and that'll be heated from reaction temperature, which is maybe 55 to 60 degrees Celsius. I've got a Celsius and a Fahrenheit. We talk in both at the plant, and so and it's not all consistent. So I have done the next slide is this identical slide with metric, and I'm going to try to stay in the imperial units for now. So we're 140 in the reactor coming out of the batch. So pretty typical reactor temperature. And we're at about 4 to 6 volume percent methanol. And over the course of about an hour, a little over an hour, we run this methanol recovery process. As soon as we see the 27.3 pass, that's our green light to move through the centrifuge, into the heat exchanger, into the flash drum, and then we build up maybe a foot or two into this drum, and then we start pumping out of this. And so it's really a continuous process the way we've designed it, and we just keep it going for about an hour to process the fuel. And if we were to say double the reactor size later, we can just increase this time here, but this system will continue running just like that. So the system, it could run 24/7 with some slight modifications. And so that's, there's a big conversation about batch versus continuous processing. And this is a continuous process here. And I think the jury's out on if continuous or batch, at what point do you want to go to continuous from batch? And it's probably, actually I don't even want to guess at what volume you want to do that. But so what we're doing is we'll get this humming along, and then it basically takes care of itself for an hour. So we'll heat from 140 at the reactor temperature. We'll take it up to about 185 Fahrenheit using the steam. And we have an energy calculation here, so we're looking at 42,000 BTUs per hour that it takes to heat from reactor temperature to flash temperature. And then we send that fuel through, there are 2 pipes that go into the flash tank. Let me see if there's a good picture here. That's one of them. So the fuel goes into here, and then the fuel goes into the other side of this tank too, through nozzles. So it's being sprayed in at heated temperature at 175 to, let's see, and being misted into here. So we're having about, is it a 30 PSI pressure drop here?
Yeah, it's going from 15 positive pressure to 20, it's actually 27, 28 inches.
Okay, yeah.
And I don't know exactly, it's close to 30 inches of pressure drop.
Yeah, so we have about 30 inches of pressure drop here, spraying into this flash drum that's at 27, 28 inches of mercury. So that's a pretty deep vacuum. And then, so the methanol boils off here as vapor. It travels through a condenser. We have a chiller loop that goes through this condenser. Let's see. That's the condenser here. This is our chiller lines here. And then the methanol travels through. We actually have a second heat exchanger. It was already installed, and we really need the cooling surface. So we have a second heat exchanger that you could size just one heat exchanger here, but this uses 2. And then we land the methanol back into the methoxide mixing tank, where we add fresh methanol to that later for the next batch. So let's see. If we're doing 365 gallons of fuel going through, getting about 13 gallons of methanol coming out. Okay, thank you. And so I think that's a critical number if you're doing methanol recovery. This is a good number to compare to. We're not in spec for flash point at that point. Like I said, we're after this, it comes out at about the flash point is at about 160 Fahrenheit, and which is 70 Celsius. So we need to get up to 140, but that is done in a really easy manner by just blowing a fan through the headspace, or we pull vacuum on the headspace. So this is what the flash tank looks like. This is what the heat exchanger looks like coming out of the centrifuge. So this is where we're heating from reactor temperature up to the flash temperature. And we've got various pressure and temperature gauges to kind of really keep an eye on what's going on. So it's coming out of the centrifuge, going through here, spraying into this tank, and then we have a pump on the bottom. And you have to be careful about the pump on the bottom that you select, because it is pulling against the deep vacuum. So you have to look at net positive suction head is the characteristic of the pump that you want to look at when you're making a selection of pumps. So you can get the NPSH from a manufacturer. This is our vacuum pump. It's rebuilt. We pretty much put it back together from, it had sit in storage for a long time, and so a liquid ring vacuum pump is not as simple as some other pumps, so there's some background reading that we did, and it took us a little while to get that back up.
And it is, I got a great deal on it as well. It's a 10 horsepower pump. It's way larger than I need, and you may be thinking that, but it's just like, I couldn't afford not to use it.
Okay, so we got about 3 minutes. Didn't leave a lot of time for questions, but there's a lot of time this weekend for conversation about it. Does anybody want to bring a question, conversation right now?
I'm curious about the glycerin that you're burning. A lot of units came out or they're burning clean?
It really...
The G-esters, yeah.
Yeah, they seem to burn very clean. I haven't seen a lot of maintenance because the glycerin, the part that would have trouble burning is the glycerin. So you're really burning at a pretty far out of spec biodiesel.
So you're hitting it with hydrochloric, drop it off, and you just have the glycerin at that point.
Yeah, glycerin's on the bottom and can be sold, and it's like, but it's like 20 or 30 FFA. I mean, it's very acidic, but I see a lot of substantially more oxidation on the copper lines. Of course,
that's the other question. So it is acidic.
Yeah.
So as far as compatibility, are you using like a certain type of nozzle, or are you having problems with it?
I haven't had trouble with it. I've got a brass nozzle.
They don't open up too big, the holes to go in like 2.5 or whatever.
I have a really large nozzle. I'm not sure what the passage is, but I've never had anything get stuck in there. I can't think. It's like the standard nozzle brand name, and like I said, I see a lot of oxidation, but all those places are like, I would absolutely just run more 1/4-inch line if I ever really have an issue with it. And I just have like forget the brand of my little boiler pump, but I just retrofitted it with the Viton seals like probably anybody's done.
I think I saw a hand up over here, and then Matt, and then Eric. What's that?
He answered my question.
Oh, okay, great. Matt?
I was just curious if you know the moisture content of your recovered methanol.
We do not have we don't have a sample poured on it, so we don't know that. We know that it is low enough that when we blend it with the other virgin oil, we don't see a yield change from all fresh. Virgin methanol, we don't see a yield change. Yeah, and Scott, sorry.
And we've like with our crude hydrometer, we're like, it's in the 98. It's like it's in the.
Have we tested the recovered methanol?
Yeah.
Okay.
From the biodiesel, not from the other traps. So,
okay.
Yeah, I think it's like 97, 98.
97, 98, what?
Percent, like 3%, like 2 to 3% moisture.
In the recovered methanol?
Yes.
And this may be the last question, Scott.
Forgive my forwardness. Capital expense for what we're seeing here, if you don't mind.
I don't really mind, but I also don't have a great answer for you because I don't know what the value is of what I have in there currently. It's way less than what I've spent on it. So I don't have a great answer for that.
All right. I think, are we out of time? Or
One more.
One more? Okay.
So rather than the glycerin wall that Bob showed, you're building up a boiler fuel wall, right?
I wouldn't describe it as a wall. I describe it as a bank account.
So ultimately, what percentage of your boiler fuel do you think you're going to use for your own process, and what percentage will you export?
I think it will be a pretty small percentage that I'll use. I am set up, I'm on a farm, and so my boiler is connected, the low pressure steam connects to hot water that heats like 4 buildings, I guess. So I'm going to run through a lot of it there and be able to sell it to the farm. But I think as far as, I think it significant, my gut feeling is that it's significantly more than supports itself energy-wise. There's some oil tanks that I would like to provide low-level heat to that I haven't done yet, so I'm not positive my total heat demand.
Probably one more you can do.
Okay, one more? Yes, John.
Okay, this isn't from a pollution perspective, more of a chemistry perspective. I'm curious about what's the
combustion, how clean is combustion if you get acrolein, do you think, or anything like that from combusting your GS?
Well, I don't think that we'd be forming acrolein because we're removing the glycerin from.
You know, like how much or?
We don't. We haven't done testing on it. What we know is that it burns clear. I can say that much.
We'll just assume it's water vapor.
CO2. I'd like to assume that. We haven't done air testing on it. I think that's a good question that will need to come up at some point. And
At what scale, I'd just be curious, you know?
yeah, and because the glycerin is largely removed, there's probably some residual glycerin in the gusters, and really the separation, we haven't done a whole lot of testing on that, and so yeah, we don't know, but we know that it burns well, and that when glycerin gets into a boiler fuel, it tends to change the burning characteristics, and it causes the flame to bounce around or go out, and then you might be able to retune it for the glycerin content in there, but we haven't had to do that, and so it's a similar setting to if we were burning vegetable oil.
And one of the nicest things, I mean, I bought the boiler with the understanding that I would be able to burn a percentage of crude glycerin in it. I don't know that I feel like that's not a reality. I can't say that for sure. But a huge issue that you have with that is it's got to be circulated all the time to keep your blend consistent. And every time you add one, you have to add the same amount of the other. So this is like, now I have just a totally consistent boiler fuel, which is like the best thing you can have, no matter what it is, right? So that you can tune your boiler accordingly.
All right. Thank you very much.